All right, so here's the next step in this little excursion we're taking, is that what I'm looking for are all the set of prisoners based on this rule. And we decided that if the absolute value of z is less than or equal to 1, then it's going to stay finite, okay, because the squaring multiplies the magnitudes, and if the magnitude is less than 1, it's going to get smaller. So if I plot all those points, what I'm going to get is a circle. Okay, so this circle is the set described by really this plus 0, that I'm not adding anything there. And the color changes happen based on how fast it takes to get away. So if I'm close to the circle, it's going to maybe stay nearby a little while until it spirals out when I square it. Okay? But it gets more interesting when we add a vector in at the end. So now we're going to, what we did before, you're going to take this number and square it. And you're going to then add this little vector. And this little vector, 0.1 minus 0.2i, looks like this. It's 0.1 minus 0.2i. So it basically looks like this. But depending where my point is, it might actually bring it closer to the origin or farther away. So it's unpredictable what's going to happen to this point. Well, we figured out that this point was a prisoner. If we plot all the prisoners, some of the ones from the circle that were prisoners before are now going to be escapees because that vector lets them move a little bit after the squared. And some of the ones that were escapees are going to be prisoners because the vector makes them move back towards in, so they may become prisoners. And if we look at all the sets, the set of prisoners, this is what it looks like. So it gets a little wacky. And this is a very rough edge. It's never smooth. And we really couldn't describe it without a computer. Now, if we go to one of these websites, and I chose this one, you can see that this number here, 0.1 minus 0.2, that's 0.1 minus 0.2i. So I can try different things. So suppose I make this a little bit bigger, and then I plot the parameters. Okay, it gets a little wackier. Suppose I make it even bigger. Gets a little crazier, right? Now maybe there are very few prisoners, but these escape slowly. We can talk more about that later. But if I make this 7, of course, a big vector, it's going to make all of them go far away. And there are no prisoners. Okay, so let's come back in here, maybe 0.4. Let's make it smaller, 0.35, 0.36. Okay, that was a big difference. Maybe if we make this minus 0.3, what's that going to do? Minus 0.35. Okay. So you can see what that's doing. That's the complex number. And what's cool is that it's this figure, which is incredibly complicated and really amazing, is based just on this one number and that simple function, square it and add this number. Okay, so you're free to play with other of the websites on that link, and the links on the homework. There we go.